Hello students, welcome to this lecture in which we're going to go back to the decimation cipher. And if you remember before the review, that lecture, we figured out that not all keys are good, like key k equals 4 doesn't work, right? We figured it out. And that's why we went to this review lecture, and now we're going back to the decimation cipher. So decimation cipher works like this. Decimation cipher works like this. So we have a key. We have I, which is a numeric value of the letter in the alphabet. What else do we have? We calculate y by taking k multiplying by I and calculating modulo 26, and this will be numeric position of the encoded letter. So by using the previous review, we have this theorem. The theorem that is a consequence of the review. It tells you that the English decimation cipher, in different language, it would be different number of letters, so it will be tiny bit different, but very close. So the English decimation cipher is valid now the rule itself: if greatest common divisor of k and 26 is equal to 1. So in other words, we can say that k and 26 are relatively prime. K and 26 are relatively prime. The same statement. Or we can say that k mod 26 is a unit. These are all expressions that say the same thing. But the only thing we need to check is this one, but actually that's the same as saying that it's a unit or it's a this pair is relatively prime. So and if we use this theorem, then if we take number 26, that's how many letters in the alphabet, and we figure out all factors would be 1, 13, and 26. 1, 13, and 26. So what values would work? Anything that is, mistake, big mistake here. Should be 1, 2, and 13, because 2 times 13 is 26. So if we write 13, we have to write 2. So anything that is divisible by 2 would not work, anything divisible by 13 would not work, and divisible by 26 would not work. Right, and they shouldn't exceed 26 because the modulo operation will wrap it up, down. So the values for k that would work for decimation cipher. So let's try to list them. So they cannot have factors of 2, 13, and 26. Let's think about 1. If we multiply anything by 1, remember, it's a multiplication cipher. If we multiply anything by 1, it's the same number, so it's not really useful to have k equal to 1. So 1 we're going to skip. We cannot use 2 because 2 is divisible by 2, so 2 we should skip. So 3, 5, nothing, no even numbers should be here. No even numbers because all even numbers are divisible by 2. So 3, 5, 7, 9, 11, 13, but 13 is divisible by 13, and therefore greatest common divisor of 26 and 13 will be 13, not 1. So 13 we cannot use. 15 is fine, 17 is fine, 19, 21, 23, and 25. That's all that would work for decimation cipher. You see, number 4 is not in this list. So this is a list of keys that would work for decimation cipher. So now we know how to encode. Now we know how to pick up the key that would work. So any odd number excluding 13 would work. And the last thing to discuss for the decimation cipher is decoding. We have not done any decoding yet. And this is, again, a big discussion for the decoding. So let's try to go through this discussion. So first, what do we want? We want to, and there is no division with modular operation in a sense, right? It's very hard to design division. So we want to multiply, we want to multiply let me restate, right? Let me restate. So we're talking about decoding, but we have to start from encoding first. So to encode what did I want to say? Still, so we want to decode, we want to multiply y, which is encoded, numeric encoded value of a letter, and let k would be the original encoding key. All right, so we want to multiply y, encoded value of a letter, by some value j such that k times j mod 26 is equal to 1. Right? So again, k is the original encoding key, and we want to multiply y, which is encoded letter, by some value j, which we don't know yet, such that k times j would be 1 modulo 26. The question is, why would it work? Why would it work, right? Why would it work? That's the question. So let's try to go through the procedure. Why would it work? To understand why it happens, we need to go through the procedure. And first, we're going to start with the procedure for encoding. So the procedure for encoding takes I, which is numeric position of a letter, of a letter and multiplies it by k. So we have a times k, or we can write k times, or we can write k times a, because it doesn't matter in which way we multiply. And to decode, we will multiply the value, because this is y, right? This is y. It's modular, but it doesn't really matter. This is value y. So we want to take y and multiply by the value j. So we want to multiply y, the value y, by j. So y times j is equal to, and for y we can put k times I, so it's going to be k times I, or I times k, right? Doesn't matter. I times k, that's for y, times j. And in multiplication we can rearrange it, and we can write it as I times k times j, but we can put parentheses around k and j. And then we want to do modular operation, so let's try to do that. I times k times j mod 26. So this is I mod 26. Remember, we learned this rule. We can split it using this multiplication rule that we learned, times k times j mod 26. But we assume that k times j mod 26 is just 1. So this term over here is just 1. So we're going to get I mod 26 times 1, which is I mod 26, which is I, because I is less than 26. And this is the original position, the original numeric position of a letter. So we went back, the original numeric position of a letter. So let's go back again. We started with I, takes I, we went to y by multiplying by k, but then we came back by multiplying by j. So that's why this procedure works. The question is, which I haven't explained yet, how to find j that would work. So question, how to find the value of j? That's the question. So let's do a small example to understand, is it easy or it is hard? Let's try. So let k equals to 5. Which j would make k times j mod 26 equal to 1? So let's try to see. We have to take 5 for k, multiply by some value of j, calculate mod 26, and get 1. But it's unclear, like 3 would work, 3 times 5 would be 15, it would be 15. But I mean, what would give us 1? It's not really clear, right? So basically, it's trial and error. So there is no nice way to do it. Or in the other ways, you can say this is a brute force pretty much. Brute force pretty much, right? Brute force. And just remember, brute force is a crazy idea, right? It takes a lot. So I'll give you a hint. J equals to 21 works for k equals to 5. Works for k equals to 5. Why would it work for k equals to 5? Let's see. If we take 21 and multiply by 5, and calculate mod 26, let's see what we're gonna get. We need to calculate 21 times 5, which is 105. So it's 105 mod 26. So you take 105 and you divide by 26. Divide by 26, so you're gonna get 4. So 4.03 dot dot dot. So we take 105, we subtract 26 times 4 to get our answer. So 105 minus 26 times 4. So we're gonna get 1. And so you see, this is really hard to figure out these J's. But actually there is a table that you can construct by using brute force table for the decimation cipher. Table for the decimation cipher. So this table, let's see if we can get it out. So this is a table for the let me try to avoid technical issues. All right, so this is a table for the decimation cipher. So this is encryption value K, this is decryption value J over here, and you can see for 5 it's going to be 21. So don't memorize this table, it will be provided on the test, but the idea is that to decrypt, so to decrypt a message that was encrypted with key K, we need to find an appropriate J from the table. And maybe exclamation point, exclamation point, exclamation point. So the last thing we're going to do for the decimation cipher is an example of decoding, because we have not done one. So example of decoding with decimation cipher. All right, so let's do this example. Decode LYGFSZ U that was encoded with decimation cipher and key K equals to 3. All right, so we have the message and we need to decode this message. So for this we're going to need an alphabet. So let's try to write down the alphabet: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So So we start with 0, 1, 2, 3, 4, 5, 6. So we number them. Sometimes it's hard to fit in, so. And we have to stop at 25 because we started counting from 0. So in total, there are 26 letters. So to decode, we need the value for J. And remember, to find the value for J, we take K equals 3 and we go to the table. So we go to table, and for value K equals 3, we have J equals to 9. So our J will be equal to 9. And that's what we will multiply by, not by K. All right, so we'll take letter L. We'll look it up in the alphabet. It's number 11. We multiply by 9. So we're going to get, and we want to do mod 26. So it's 99 mod 26. So maybe here on the side we're going to do the calculation. So we take 99, we divide by 26. So it's 3.8, 3.8 dot dot dot. So that means 99 minus 26 times 3. 99 minus 26 times 3, so we're going to get 21. 21, that's our answer. We look up number 21, that's letter V. The next letter that we have to decode is letter, which one? Letter Y, right? Letter Y. So we do letter Y, we'll look it up in the alphabet. Y is at the end, that's number 24. So it's 24 times 9 mod 26. Again, we use a calculator, so we do 24 times 9, 216 mod 26. So we take 216, we divide by 216 divided by 26. So it's 8, right? So we do 216 minus 8 times 26. So we're going to get 8. 8. So we look up 8, that's I. Then the next letter we need to do is G. So we look up G in the alphabet. G is 6 times 9 mod 26. So it's going to be 54 mod 26. And 26 times 2 is 52. So it's 54 minus 52, or 26 times 2 will be 2. So we'll get number 2, and 2 is C. The next letter we need is F. So to get F, we'll look it up. F is 5 times 9 mod 26. So it's 45 mod 26. So it's 45 minus 26. 45 minus 26. So we do this out. So it's 19. So we get 19. And 19 in the alphabet is T. Right? Couple more letters left. S. S is 18. 18 times 9 mod 26. So we do 18 times 9 is 162 mod 26. So we take divide by 26. So we know 6 times. 6 times. So it's 162 minus 6 times 26. So we're going to get 6. And number 6 in the alphabet is Did I do it right? Did I do it right? S. One more time, sorry. Didn't, so 18, right, that's S. S is 18 times 6. That's 6, sorry. 18 times 9. 162 divided by 26 is 6. So 162 minus sorry, got started checking out. Apparently, it shouldn't be S, it should be Q. I made a mistake when I did it out. All right, so let's do not S, but Q. So Q is 16. 16. Let's try to do that. 16 times 9 divided by 26, it's 5. So 5 times 26 minus 144. So we get 14. Yeah, so it should be 144, and this should be 14. And 14 is O. All right. So the next letter we need to do after Q is Z. So we take Z, we look it up. Z is 25. 25 times 9 mod 26. So let's do this out. So we have 25 times 9, so it's 225. 225 mod 26. We divide by 26, so it's 8. So we take 26 times 8 and we subtract it from 225. So we're going to get 17. I got negative 17 because I subtracted it in a wrong order, but it's still going to give us R. And you can probably guess the last answer. I'm not going to do it. You can try. The last letter is U, and we will get Y. So victory. We beat the decimation cipher. We'll practice a little bit more in class, but that's the end of this lecture.